Welcome back, friends. Welcome to another video sessions from Biology. In the previous video lecture, if you remember, we talked about the early protein inhibitor, or we talked the fumaversin, the mechanism of action, resistance in a detail. Now this is the sixth video, or we can say this is the fifth video regarding with the antiviral drugs. And in this video lecture, I'm going to talk about the another drugs which are usually involved to inhibit the nucleic acid synthesis, or we can say to inhibit the DNA synthesis. Fine. And these drugs are called as we can say a reverse transcriptase inhibitor. Reverse transcriptase inhibitor. Or we can also write, just in short form, we write RTI. Now in reverse transcriptase inhibitor, there are two drugs which are involved. The one drugs which are known as TI. Now the drugs which are involved in reverse transcriptase inhibitor, we usually call that NRTI, nucleotide reverse transcriptase inhibitor. And the second drugs which are involved in this case, we call that non-nucleoside reverse transcriptase inhibitor, NNRTI. Fine. So the drugs names of these means the drugs names which are included in this non-nucleotide reverse transcriptase inhibitor, we usually call that intravirine, or the drugs which are involved in this case, Absavir. So the drugs which are involved in non-nucleotide reverse transcriptase inhibitor, we usually call that intravirine, and the drugs which are involved in nucleotide reverse transcriptase inhibitor, we usually call that Absavir, or we can say Abcavir. Fine. So these are the drugs which are involved in the reverse transcriptase inhibitor. Fine. Let me talk the antiviral spectrum of these drugs. Antiviral spectrum. Now if we talk the antiviral spectrum of these drugs, what does it mean? It means on which kind of viruses these drugs are activated. So usually in case of HIV, these drugs can show best result. Okay, now let's talk about the mechanism of action of these drugs. So first of all, we will talk about the nucleotide reverse transcriptase inhibitor, their mode of action and resistance. Fine. And after that, then we will talk the non-nucleotide reverse transcriptase inhibitor, their mode of action. Fine. So now let me explain. Now in case of nucleotide reverse transcriptase inhibitor, what happened actually? In this case, let's suppose we take the HIV virus. Now before going to explain these drugs, you need to understand the life cycle of the HIV viruses. I already discussed it, so if you missed that video, so go back to my channel and watch the video which are regarded to HIV life cycle. So first watch that video and then come back to this video. Fine. So now in this case, let's suppose we take the HIV viruses. The HIV viruses, in this case, let me draw the structure of the HIV viruses. So let's suppose this is the HIV virus. Fine. This is the envelope area of HIV. Sorry, not envelope area, the capsid area of the HIV. They have the envelope. Inside this, they carry the two strands. We call that messenger RNA. There are some spikes protein arises. And these spikes protein are available to attach on the host cell. Now let's suppose this virus get internalized inside the host cell. Once they were internalized inside the host cell, so what they do, they will release the capsid area. And once they will release the capsid area, then this capsid area will start degrading, although it contains the messenger RNA and the reverse enzyme also, reverse transcriptase enzyme also. So this capsid area or this protein coated area will be start degrading, or we can say these protein will be uncoated. Once these protein are uncoated, then they will release what? They will release the messenger RNA. So once they will release the messenger RNA, then this messenger RNA will passes from the, let's suppose this messenger RNA will passes from the reverse transcriptase enzyme. This is the structure of the reverse transcriptase enzyme. So the reverse transcriptase enzyme, if you watch the reverse transcriptase enzyme, so usually the reverse transcriptase enzyme will be just like in this form. Fine. So once they are passes from the reverse transcriptase enzyme, then what we get? We get RNA DNA hybrid. This blue strand represent the DNA and this red one RNA. So we get DNA RNA hybrid. This strand again passes from the reverse transcriptase enzyme, and after that what we get? We get the double stranded DNA. Fine. So once we get the double stranded DNA, then what happen after that? This double stranded DNA will encrypt it with the host genome. Means this double stranded DNA will reach it to the host genome by integrase enzyme. Once they reach to the host nucleus, then they will be attached to the host genome, and after that replication of HIV viruses will be started. Fine. So what actually these drugs do? This nucleotide reverse transcriptase, these drugs do. These drugs will actually stop the DNA synthesis, we can say. Let's suppose in this case, let's suppose what happened. Let's suppose in this case, this blue one, let's suppose this red strand, means this messenger RNA will be eliminated out. And what happened if this blue strand, if I assume this, the structure in a detail, this blue strand, let's suppose, what happened here? Let me draw the enzyme with a black marker. The enzyme will sit here, means when the blue means when the DNA, the single stranded DNA, when again passes from here, let's suppose this is the single stranded DNA, it is again passes from this reverse transcriptase enzyme for this purpose to make a double stranded DNA. Fine. Now whenever they are passes from the DNA strand, so here are some nucleotides are present, and we call that deoxynucleotides. Fine. So here there are some deoxynucleotides are present. Let me draw here with a blue marker. Now these are responsible to receive the other deoxynucleotide which are complementary to these nucleotide. Fine. So if I draw the structure of these nucleotides, so these nucleotide will be just like in this form. Just like in this form. At that area there are 3 hydroxyl group, and this is 5' end, this is 3' end, and at 3' end there are hydroxyl group. Fine. So they will come here and they will bind to that area. Fine. So they will bind to that area. This cone like shape means this cone like shape represents what? This cone like shape represents means there are the 3 hydroxyl group are present. Now in this case, due to this 3 hydroxyl group, the other nucleotide means will easily be binded. So the other deoxynucleotide will easily be binded. Now this is the other nucleotide. So they will be easily binded. Fine. So then the third one, the fourth one, the nucleotide will be binded, deoxynucleotide will be binded, and then we get what? We get this double stranded DNA. We get this double stranded DNA. So we get a long DNA chain. Fine. Actually, how these chain are linked to each other? These means this nucleotide, deoxynucleotide, will be linking to each other with the presence of this hydroxyl group. So with the presence of this hydroxyl group at 3' end of this deoxynucleotide, the other nucleotide will be easily binded. See, this is the 3 hydroxyl end. So due to this end, the next deoxynucleotide will be easily binded, and then next one, and then next one. Fine. Now, what actually the drugs do here? The drug structure will be just like in this form. If I draw the drug structure in a red one, so the drug structure will be look like in this form, but here just one missing, and we call that this square area represents that no hydroxyl group will be present here. So what happened? This drugs, let's suppose these drugs will bind here. So here are the hydroxyl group due to which the drugs can easily be bind. So here are the hydroxyl group and the drugs will bind here. Fine. But in this case, the drugs don't carry what? They don't carry the hydroxyl group. They lack the hydroxyl group. Due to this lacking, this next drugs will not bind to that area. Why? Because here no hydroxyl group. If no hydroxyl group is present for the attachment, so how this one deoxynucleotide will be added here? How it is possible? It is not possible. Fine. So this is the drug, and we usually call that NRTI, means Abcavar. So the Abcavar will bind here or NRTI will bind here, due to which it can halted the DNA chain, and we call this phenomena chain termination. What we call that? We call that chain termination. So then chain termination will occur. Fine. So here chain termination will occur and no nucleotide will be binded here. So this is what happened. The reverse transcriptase enzyme, whenever they are moving in this direction, so then the nucleotide will be added. Fine. When the reverse transcriptase enzyme are moving, then the nucleotide will be added. Otherwise, the nucleotide will not added when this enzyme will not move. So they will move in this way, due to which the nucleotide will easily bind it. Fine. Now these, when the nucleotide are binded to each other, so here 5' and 3' phosphodiester bond. So between these two nucleotides, means there are 5' to 3' phosphodiester bond. Phosphodiester bond are present. Fine. So phosphodiester bond, we call it 5 to 3' end. When the drugs are bound here, so no more 5 to 3' phosphodiester bond will be occur. So when the 5' to 3' phosphodiester bond are not linked due to the presence of these drugs, then chain termination phenomena will occur. We call that chain termination. Why? Because the DNA chain will be terminated, or we can say the DNA in this case is incompleted. The DNA strand, the second strand of the DNA is incompleted. Finally, the DNA, when the double strand DNA are not present in this case, so this DNA strand will not encrypted, and when they are not encrypted, then the replication of the viruses will be not occur. This is the simple mode of action of this non-nucleotide reverse transcriptase inhibitor. But the virus also show some resistance against these drugs. Against these drugs, the virus shows some resistance. Fine. In this case, this enzyme will be mutated. Fine. So this enzyme will be mutated. The N-terminal end means this end of the enzyme will be mutated. Now due to this N-terminal end of the enzyme, when the drugs are binded, then they will repel out. So let's suppose the enzyme are binded to that area. Fine. So what actually this do? So they will just like this drug form. They will just like in this drug form. And you better know that positive will repel each other, negative will also repel each other. So let's see, this one is also in red form, and this mutation, let's suppose this mutation is also in red form. So due to this mutation, what the drugs do? They will eliminate it. So they will eliminate out it. So the drugs will eliminate it from this single stranded DNA. So once the drug will eliminate it, then again the nucleotide will bind it here. So again another nucleotide will bind here, and again the process will be started. And if again the drugs will come here, they will again cleave these drugs and eliminate it from this single-stranded DNA. Fine. And finally DNA chain will be formed and we get a double-stranded DNA, and the replication process will be started. So this is the resistance which are activated against these drugs. Means in this case the reverse transcriptase enzyme will be mutated, due to which the drugs will be cut, or we can say the drugs will be eliminated from this strain. Fine. So this is the mechanism of resistance of these drugs. Now let's talk about the next one drugs we call that non-nucleotide reverse transcriptase inhibitor. In this case what happen, these drugs will directly bind to the enzyme. If I draw the structure, means this one enzyme, if I draw here once again, let's suppose this is the enzyme. This is the active site of the enzyme, fine. And these one side, I draw here, these one are the P66 subdomain. These are the P66 subdomain. And due to these P66 subdomain, the drug structure will be just like in this form, and or we can say the drugs will be just like in this form. So this is the drug. Usually we call that entravirine. This entravirine will bind here. See? So once the entravirine will bind here, so they will be not fit to that area. They will not attach to that area due to this blockage. Due to this blockage, they will not bind it. Let's suppose this is the enzyme and this is the messenger RNA. Let's suppose this is the messenger RNA. So once the messenger RNA, the enzyme will easily bind to that area, because here at this active site is free. So once this active site is free, so they will easily bind and they will scan the messenger RNA or the DNA and produce DNA-RNA hybrid or double-stranded DNA. Fine. If the drugs, let's suppose this black one represent the drugs are fitted here. So how they will? So they will not bind it to this messenger RNA or DNA. They are not binded. Fine. So this is the mechanism of action of this non-nucleotide reverse transcriptase inhibitor. Now the resistance which are activated against these drugs, so what happened in this case, the enzyme will be changed. This P66 subunit of the enzyme means at that area, let's suppose if I draw here in a mutated form, so this enzyme will be what? Mutated. So this P66 area, here some finger-like structure arises. These means these one are the finger-like structure. Now due to this finger-like structure, this active site which are present, the enzyme will not reach it to this active site. Why? Let's suppose here the enzyme are binded, but due to this binding, the active site, means this active site will be not binded to this one area. So once the drugs will not bind to the active site of the enzyme, then the enzyme will easily eliminate it. So they will eliminate it out. Right? So they will be out from the enzyme. So once they will out from the enzyme, this enzyme will again, means this mutated enzyme will again sit here and they will scan the strand and produce a double-stranded DNA. Fine. So this is the mechanism of resistance of these drugs. See, the drugs are not binded. The drugs will come here and this site area will not bind to the active site of the enzyme. So this enzyme will sit here and again the replication process will be started. So this is another resistance which are activated against these drugs. Now let me tell some adverse effect of these drugs. If still we are giving these drugs, so there are the adverse effect of these drugs also. Now what are the adverse effect? First of all, let me write the adverse effect of this one drugs here. skin rashes, second, what does it mean? Elevation of liver enzyme means that the enzyme will be injured due to the use of these non-nucleotide reverse transcriptase inhibitor drugs. Due to these drugs, the adverse effect means that this elevation of liver enzyme means that due to these drugs, the liver will be injured, by which the enzymes are released in a lot of number. Now, if we talk the adverse effect of this NRTI, so now let me write adverse effect of NRTI. Now the adverse effect of nucleotide reverse transcriptase inhibitor is nausea, vomiting, osteomalacia. What does osteomalacia means? Osteomalacia means that the bone will be weak or the bone will be soft. Why? Due to giving these means these nucleotide reverse transcriptase inhibitor drugs, or we can call that Apcavar. So due to these drugs, they will suck or they will absorb the vitamin D and or calcium. So due to the deficiency of calcium or vitamin D, also osteomalacia will be occur. Means the bone will be soft. So this is the reverse transcriptase inhibitor drugs, the mechanism of action, resistance, and everything. Fine. I hope you understand this video. If you understand, so best of luck. If you have still any kind of question in your mind, so write it into a comment. I will try my best to give you answer as soon as possible. Fine. So this is the 5th or 6th one video regarding to antiviral drugs. Inshallah, in the 6th or 7th video of the antiviral drugs, we are going to talk about the last drugs, and we call it neuraminidase inhibitor drugs. Fine. The drugs which are used in the neuraminidase inhibitor, their resistance, mode of action, and adverse effect also in a detail. So it will be it will be our last video of this antiviral drugs. Fine. So stay tuned and continue to watch. Thank you so much.